Assalamualaikum. My name is Nufara Akila binti Jamaluddin. My matrix number is 01 DKA2A 1033. I am from DKA2A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akila binti Abdul Aziz. My matrix number is 01 DKA2A 1034.
My name is Lily Elena. My registration number is 01 DKA21F 1026.
Hai, Assalamualaikum and salam sejahtera. My name is Alina Fisa binti Nur Azizul. My number matrix is 01 DKA21F 1012. Today we want to present about chapter 2, basic differentiation. Introduction. This topic explains more on the technique of differentiation. It covers the basic rules of differentiation, derivative of trigonometric, logarithmic and exponential functions, second order differentiation, parametric equation, implicit differentiation, partial differentiation, and technique of total differentiation. It also explains application of differentiation in calculating the rates of change in addition, solving maximum and minimum problems. Introduction of differentiation. Differentiation is used widely in solving problems, especially in engineering, medical, commerce, agriculture, and many other fields. When you find the rate of change of a quantity with respect to other quantity, you are actually doing differentiation. Another name of differentiation is the derivative of the function. If the person is running up a hill, his vertical height will change with respect to horizontal height. Its cancel is gradient. Gradient equal change of vertical height over change of horizontal height. Generally, to find the differentiation of y with respect to x, just write the symbol dy over dx to represent it. If y is a function of x, then y equal fx. The differentiation of y with respect to x, dy over dx can be written as fx. Therefore, dy over dx equal fx. Now I will pass to Farah Akila to continue the presentation.
Differentiation concepts are applied in displacement and velocity. Velocity v is the differential or displacement s unto time t and written as ds over dt, while acceleration a is differentiation of velocity v unto time t and is written as dy over dt. Differentiation is a technique which can be used for analysis the way in which functions change. In particular, it measures how rapidly a function is changing at any point in engineering application the function may. For example, represent the magnetic field strength of a motor, the voltage across a capacitor, the temperature of a chemical mix, and it is often important to know how quickly these quantities change.
This is an example of differentiation in a real life. Example 1. Differentiation can be applied in our daily life to solve our daily problems. We can use the differentiation to determine the maximum and minimum values of particular function, such as cost, strength, and amount of material used in a building. Differentiation are also be used in many engineering and science problems, especially modeling the behavior of moving objects. Example 2. Other than that, differentiation also can tell you at which speed you are driving. This is because differentiation can determine the speed or distance covered, such as miles per hour, kilometer per hour. Example 3. Last but not least, It can also be useful to business people. This is because differentiation can help you calculate the profit and loss of the business just using graph and help you to predict fluctuation of the stock market in future. This is the questions. Question A. Use differentiation to find expression for dy per dx. Question B. Find the coordinate of any stationary point on the curve. Question C. How many stationary points does the graph have? Question D. Determine y-intercept point. Question E. Determine the nature of any stationary point you found in part C, justifying your answer. And the last question is sketch the graph of the curve.
Question A. Use differentiation to find expression for dx over dy. Firstly, you have to write y equal 3x power of 3 plus 2x power of 2 minus 5x plus 7. dy over dx equal 9x power of 2 plus 4x minus 5. 9x minus 5 and then x plus 1. It will get factorization. Thank you.
Question B. Find the coordinate of any stationary point on the curve. For a stationary point, dy per dx equal 0. X minus 5 equals 0, x equal 5 per 9, x plus 1 equals 0, x equal negative 1.
How many stationary points does the graph have? Is 2. 5 over 9, negative 1.
Now I would like to continue my presentation. Okay, when x equal to 5 over 9, okay, so y 3x squared plus 2x cubed minus 5x plus 7, y x we need to change with 5 over 9, so 5 over 9 square plus 5 over 9 cube minus 5 over 9 plus 7. Then y we can you can get 1301 over 243. Okay, next when x equal to negative 1, y 3x squared plus 2x cubed negative minus 5x plus 7, y x we need to change with negative 1, so 3 negative 1 square plus 2 negative 1 cube negative 5 negative 1 plus 7. Then you can get y equal to 11. So 5 over 9 1301 over 243, then negative.
Determine the nature of any stationary point you found in part C, justifying your answer. So, dy per dx equal 9x square root plus 4x minus 5. d square root y per dx square root equal 18x plus 4. Now, when x equal 5 per 9, we must to change x to 5 per 9. So 18 multiply 5 per 9 plus 4 equal 40. And then we change x equal negative 1. 18 multiply negative 1 plus 4 equal negative 14. So the answer of the stationary point is 5 per 9 and 1301 per 243 and negative 1, 1. So the answer of t square root y and per tx square root is 14 is a minimum point and negative 14 is a maximum point.
Sketch the graph of the curve. This is stationary point 5/9 1301/243 and this 2.04 maximum point is negative 1, 1. Once we have taken the differentiation of a function f, once we can take the differentiation again. This is called the second differentiation of the original function f and equals the instantaneous rate of change of f. In the example above, this corresponds to how quickly Otis is speeding up or slowing down. That is his acceleration. We can continue in this manner as long as we like, taking successive differentiation.